Unit 4-5, trapezoids. Now, a trapezoid is not a parallelogram. A trapezoid is not a parallelogram. We're going to talk about why it's not in just a second. Here's the definition of a trapezoid. It is a quadrilateral with, here's the key to why it's not a parallelogram, exactly one pair of opposite sides parallel. Now, a parallelogram is a quadrilateral with both pairs of opposite sides parallel. A trapezoid is a quadrilateral with exactly one pair of opposite sides that are parallel. The parallel sides are called the bases. We can call them base 1 and base 2, or upper base and lower base. So the bases were side AB and side EF. The non-parallel sides are called legs. The median of a trapezoid is the segment that joins the midpoints of the legs of the trapezoid. The median is segment CD. It is a segment, excuse me, it is a segment that joins the midpoints of the legs. I probably should say the segment because it's not a segment, it's the segment. There's just one. The segment that joins the midpoint of the legs of the trapezoid is called the median of the trapezoid. So a trapezoid is a quadrilateral with exactly one pair of opposite sides parallel, which means it's not a parallelogram. The opposite sides that are parallel are called the bases. The other two sides are called the legs. The segment that joins the midpoint of the legs is called the median of the trapezoid. Now remember, on a triangle we said an isosceles triangle was a triangle with two equal sides, and we called the two equal sides the legs. So an isosceles trapezoid then would be a trapezoid that has equal legs. A trapezoid that has equal legs. Now, just like in an isosceles triangle, if two sides of a triangle are equal, then the angles opposite those sides are equal. If we were to kind of take off the top of that triangle, with a line that's parallel to the bottom, well, we've got the trapezoid. In fact, what we have is an isosceles trapezoid. And you can see that in an isosceles trapezoid, those base angles are equal because they really were the base angles of that isosceles triangle that just got the top of it chopped off. So we can see that in an isosceles trapezoid, the upper base angles are equal and the lower base angles are equal. In an isosceles trapezoid, the upper and lower base angles are equal. Upper base angles equal. Lower base angles are equal. The bases are parallel. Same sides make a C and their supplementary. So you can see that those add up to 180 because they're same side interior angles. Same sides make a C and their supplementary if the lines are parallel. We define the median of a trapezoid. We'll define it again. It is A or the segment joining the midpoints of the legs. So a median of a trapezoid is the segment joining the midpoints of the legs of the trapezoid. There's two properties of the median of a trapezoid. Number one, the median is parallel to both bases. If we were to draw the median of this trapezoid, it would be parallel to both bases, and the length of the median is half the sum of the bases. It's the average of the lengths of the bases. Half the sum, the average. The median is the average of the lengths of the bases are 1/2 the sum of the lengths of the bases. Okay? Example. If indeed CD is the median of this trapezoid, which we can see that it is because it joins the midpoint of the legs, that means that it must be parallel to both bases, and its length is half the sum of the lengths of the bases, or the average of the lengths of the bases. So it's half of their sum, which is 15. We could use the formula that the median x plus 1 is half the sum of the bases. We could plug our bases here, x minus 3 and 2x minus 4. I'm just going to write this bigger. Median x plus 1 equal 1/2 the sum of the bases, upper base being x minus 3, lower base being 2x minus 4. And we could actually solve for x, and we could find the median in both bases. Let's do that. To do that, we would follow the order of operations, and we have parenthesis and multiplication. We can do what's in the parenthesis in the way of combining like terms. And so we're going to have x plus 1 equal 1/2 times open. X plus 2x is 3x. Negative 3 and negative 4 is negative 7. If we would like to get rid of that 1/2 so that there's not a fraction, we can multiply the right side by 2 over 1 and multiply the left side by 2 over 1. Now that's times a sum, which is a higher operation hitting the lower operation, so we put the lower in parentheses. That putting the parentheses is discussed in the Algebra 1 text on page 37 and page 171. multiplying through by the common denominator to eliminate the denominators is discussed in Chapter 8 of the Algebra 1 text on page 232 of the Algebra text. So the multiply through by the common denominator trick to eliminate the denominators is on page 232 of the Algebra 1 text. So we're going to distribute it here. 2 times x is 2x. 2 times 1 is 2. On the right side, the 2 cancels the half, and so we have 3x minus 7. Now, we're doing the order of operations horseshoe on page 33 along with all of that distributive law and getting rid of the denominator trick and all of that. We've done all we could do to simplify either side as far down as we can. So now we're going to do what the bottom of the horseshoe on page 33 says. It says get the variable that you're isolating on one side of the equal sign, remembering to change the sign when you cross over. And so you're going to have negative understood 1x, and I'll just go ahead and put the 1 there for a second, plus 2 is equal to negative 7. Don't forget to put that minus as a sign on the 7. Now we have multiplication and addition. We're going to undo addition by subtraction. So we have negative 1x is equal to negative 9. The signs were both negative on the 7 and the 2. When you add or subtract with the same sign, you add and take the common sign. Now we're going to undo multiplication by division, and we get x is equal to 9. Now we didn't find the median or the basis, we found x. To get the median and the basis, we need to plug that in. The upper base would be x, which is 9 minus 3, which is 6. The median would be x, which is 9 plus 1, which is 10. The lower base would be 2 times x, which is 9 minus 4, which is 18 minus 4, which is 14. If you want to kind of check that out, you can see that if you took 6 plus 14, you would get 20, half of which is 10, and so it checks out. Any questions on theorem 416? The median of a trapezoid is 1/2 the sum of the bases of that trapezoid. The median of a trapezoid is 1/2 the sum of the bases, or we could say the median is the average of the bases. Okay? We're going to go ahead and do the daily work on this since it was a little bit shorter assignment. Remember that I'll get there in a minute. A trapezoid is a quadrilateral having exactly one pair of opposite sides parallel. The opposite sides that are parallel are called the bases. We can call them base 1 and base 2, or we call them upper base, lower base. They're not always setting like that. They could be sideways. The other two sides are called the legs. The segment that joins the midpoints of the two legs is called the median. So there's the parts. You can fill all of that in. If those are parallel, then same side interior angles are supplementary. So we can take 180 degrees minus 75 degrees, and we would get 105 degrees for this angle up here. Same sides make a C, and they're supplementary if the lines are parallel. and you can kind of continue from there. Going to be a little bit of algebra involved in finding the pieces and parts of the bottom one. To find AB, remember AB is the median, and the median can be found by taking 1/2 the sum of the bases, and the bases are your 6 and 12, so you would plug those in and solve. We'll kind of get you set up here. Remember that on finding RQ, it is the median. We know that the median 2x is equal to 1/2 the sum of the bases. The upper base is x plus 3. The lower base is 2x plus 7. So we get the equation median 2x is equal 1/2 the sum of the bases, x plus 3 and 2x plus 7. And you're going to solve that as we showed you how in the example. You will do some combining like terms within the parentheses. You will remember you could distribute the half, but if it's going to give you fractions, then you could eliminate the fraction by multiplying through by the denominator 2. Then you'll get all your variables on one side, remembering to change the sign when you cross over and then undo. So we're going to use the order of operations horseshoe to solve with. Gets a little bit tricky to do this draw and label an example accurately. Let me show you just a little bit how to get started. It says the lower base is 56 millimeters. And so you would get your centimeter ruler, and you know that the things about the width of your thumbnail are 1 centimeters. And the little bitty guys in between, about the width of a pencil lead, are millimeters, and it takes 10 milli to make a centi. And so you would go to 56 millimeters, would be 5, 10, 20, 30, 40, 50, 1, 2, 3, 4, 5, 6 of those little bitty marks, see? Millimeters, that's the lower base. That's CD. The angle at C is 50 degrees, so you would lay your protractor in here. Put the vertex on 0, work your way over here to 50, make a mark, cut it in that way. And then there's some figuring and calculating to do in that, which is a part of your assignment. So that gets you started, but you got to do some thinking before you figure out what all the angles are and what all the other pieces are and all of that. So we'll let you draw, figure, work on those. Number 17 is an odd one, so it's in the back of the book. It's at the end of the chapter as far as odd answers. That could help you out, or you might get some help from someone there. Let's go on to the next section. Let's take a look at finding the median of this one, because it's going to involve some quadratic stuff. Using our formula, we know that the median, which is this, is equal to 1/2 the sum of the bases. The upper base is 3x squared plus 10x minus 19 plus the lower base, which is 4x squared plus 8x minus 10. And then we would solve. Now, to solve, the first thing we could or would do is combine like terms within that parenthesis. And so we would have 3x squared plus 8x plus 3 equal 1/2 times, combine our x squared, 7x squared, combine our x's, 18x, combine our numbers, minus 29. Now, we don't like that denominator, and if we distributed the half, we would get fractions, and we don't want to deal with that. So we're going to multiply through by the denominator 2, which will eliminate that fraction situation. But over here, we have to distribute it. So we're going to have 6x squared plus 16x plus 6 is equal to 7x squared plus 8x minus 29. Now what we have is a quadratic. Before we can solve a quadratic, we need to get it in standard form, which is ax squared plus bx plus c equals 0. This quadratic is not equal to 0, it's equal to all of that stuff. So we need to zero that side out, and we do that using additive inverses. Which cancels, and we get a 0. What you do to the right side, to balance it, you have to do to the left side. We're going to put our like terms together. And then combine like terms using sign rules. And then we're going to solve that quadratic. Now, we could make this a little bit simpler to try to factor by making a equal to 1. And we could do that by dividing by 1, which would distribute itself here. And we would get x squared minus 8x minus 35 equals 0. That means we can look for things that multiply to give you 35, which is the only thing you can get to 5 and 7, and add to give you 8, and there's no way that's going to work, which means that this is not a factorable quadratic. So you can't factor it using the easy method when a is 1. You can't factor it using the AC method. You're going to have to use the quadratic formula, and we're going to get not so pretty answers, which is fine to have not so pretty answers. And so we're going to plug that into the quadratic formula since factoring didn't work out for us. The quadratic formula is on, we learned it studied it in the preliminary pages of chapter 4, but it's also in the Algebra 1 textbook on page 221. The a of this quadratic is the 1, the b of the quadratic is -8, and the c of the quadratic is -35. The quadratic formula is x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we're going to take this a, b, and c of the quadratic and plug it in. So we will have x is equal to the opposite of b. B was a negative 8, the opposite of which is a positive 8, plus or minus the square root of. Now, we have b squared. We talked about on page 171 of the 170, excuse me, of the Algebra 1 text that if you intend to square a negative number like negative 8 squared, that negative will separate itself from the 8 and become a negative 1 times 8 squared so that the negative doesn't also get squared. To make sure that the negative doesn't separate itself and that it gets squared also, we trap it in a parenthesis. So we have negative 8 quantity, we say squared, the opposite of b, square, minus 4 times a, not the opposite of b squared. The opposite of b plus or minus the square root of plain old b, which is negative 8 squared, minus 4 times a, which is 1, times c, which is negative 35, all over 2 times the a value of 1. Now there's 3 pieces that we're going to do in the first step of solving. We're going to do that piece, we're going to do that piece, and we're going to do the denominator. So that's going to give me x is equal to 8 plus or minus the square root of 8 squared, negative 8 squared, which is positive 64. We're going to multiply all of this. It's a negative 4, a positive 1, and a negative 35. That's an even number of negatives. When you multiply with an even number of negatives, the answer is positive, so we put a plus. 4 times 1 is 4, and 4 times 35 is 140. All over 2 times 1 is 2. We're now going to complete what's under the square root. And so we're going to have x is equal to 8 plus or minus the square root of 64 plus 140 is 204. All over 2. The square root of 204 we will break down according to the rules on page 15 and 16 and also on page 248 in Algebra 1 text. So 2 goes into that, 102. 2 goes into that, 51. 3 goes into that, 27. 17, excuse me, that was kind of weird, wasn't it? 17. And 17 is prime. So we would rewrite it as the product of its primes, 2 times 2 times 3 times 17. Make a new radical. Circle sets of 2 for square root, 3 for cube root, 4 for fourth root, etc. From each set, you bring one out. What didn't get circled in a set goes back in. If there's more than one outside or more than one inside, you multiply. So we multiply the 2 on the inside back together, and we get 51. And so that simplifies into 2 square roots of 51. And so we have x is equal to 8 plus or minus 2 square roots of 51 over 2. Nice, pretty little problem we got going here. The 8, the 2, and the 2 all have a common factor of 2. So we can simplify that into x is equal to 4 plus or minus square root 51, because 2 goes into 8, 4, and 2 goes into 2 once. It had to divide into both evenly, or we couldn't have reduced like that. So we have x equal 4 plus or minus square root of 51, which means that x is either equal to 4 plus square root 51, or x is equal to 4 minus square root 51, one of the two. Now, if we want to find A, B, C, D, E, F, we have to plug that in. Now, that's kind of fun, isn't it? So let's just find one of those. Now, we learned how to add, subtract, multiply, and divide everything in the Algebra 1 book. In page 1, we learned how to add about anything. On page 5, we learned how to multiply about anything. And then way over there in chapter 9, we came back on page 246 and learned how to add radicals better. On page 247, we learned how to multiply radicals better. And on page 248, we learned how to simplify radicals. But if you want to look back there, you can. Let's just say we want to find AB. AB was the upper base. It's 3x squared plus 10x minus 19. And x is 4 plus square root 51, or 4 minus square root 51. And so we're going to have 3 times 4 plus square root 51 quantity square plus 10 times 4 plus square root 51 minus 19. Now, if you got a graphing calculator and you'd like to just punch that in, you can, or we can write it as a radical in simplest form. I'm going to go ahead and solve this just to say we did. What's going to happen right here is we're going to have a binomial times a binomial. Now, let me talk about how to do that. I'm sorry, I'll get this right. 4 plus square root 51 times itself, 4 plus square root 51. The way I teach this is not the FOIL method as some are used to. I teach this on page 200 of the Algebra 1 text to distribute the first binomial through the second binomial. So we would write down the first binomial twice. And then times the first piece, because we're distributing that onto the first piece, 4. And then times the second piece, square root 51. And then we would distribute again, so we would have 16 plus 4 square root 5. Distribute again, plus 4 square root 51. And this is a 51. I keep making mistakes, which is not nice to do at all. I put 5s instead of 51s. It's not good when you have such a big problem to make mistakes. and then plus square root 51 times square root 51. And so then we could combine like terms, our numbers with our numbers, and our square root 51s with our square root 51s, and we would have 67 plus 8 square root 51. Now, that's the result of doing the exponent. We have that times a 3. Right here, we're going to distribute the 10, have a plus 10 square root 51, and then we still have the minus 19. We're going to distribute again. We're going to have 3 times 67 is 180, and 21 is 201, plus 3/8 are 24 square roots of 51, plus 40, plus 10 square roots of 51, minus 19. And then we would combine like terms. We would have 201 plus 40 is 241. 241 minus 19 would be 222. And then we combine our square root 51s plus 34 square root 51. That would be the answer to AB as a radical in simplest form. 222 plus 34 square root 51. Now, I really hope I didn't make a mistake way up there easier and that came out to be something like 7 or 8. That would be kind of bad. But even if I did mess up, you sure got a lot of good explanation of how to simplify radicals and how to multiply binomials, regardless of whether that was correct or incorrect. And I'm going to leave the rest for you. You can, if you like, look at the odd answer on C, and you can check that out maybe in the back. Let's take a look at, I did make a mistake on that. It's way back in there. We should have set it up like we did to start with. You would have combined like terms. You would have multiplied both sides by 2 to eliminate the denominator. You would have moved everything to the left and set it equal to 0. When you move it all to the left, after all that's said and done, let me go back and fix it. I apologize for making a mistake, but look at all the good math we got to go through. We looked at the quadratic formula. We looked at simplifying radicals. We messed with some pretty messy algebra. So if you watched all of that, you got a bonus. Although you probably may wish you hadn't got it. And I apologize that I gave it to you that way. But let's go back and let's see if we can get it right this time. Okay, so what we have is median 3x squared plus 8x plus 3 is equal to 1/2 the sum of the bases, upper base 3x squared plus 10x minus 19 plus lower base 4x squared plus 8x minus 10. We're going to combine like terms. we will have 3x squared plus 8x plus 3 equal 1/2 open. 3x squared plus 4x squared is 7x squared. 10x plus 8x is 18x. Minus 19 minus 20 is minus 29. We don't like that fraction, so we're going to multiply by its denominator 2, which will get distributed on the left. And so we will have 6x squared plus 16x plus 6 is equal to 7x squared plus 18x minus 29. And the 2 wiped out the 2. We now want to set it equal to 0, so we eliminate the right side using additive inverses. What we do there, we do over here. And so we're going to have negative 1x squared minus 2x plus 35, and that was our mistake, was that minus 2x. I didn't have a minus 2x a while ago. I'm not sure what I did. Whoever was watching probably saw that and thought, uh-oh. You might have fast forwarded if you were smart. Anyway, so we can go ahead and divide by that negative 1 again like we did a while ago to make a be 1, so it's a little easier to factor. So we're going to have x squared plus 2x minus 35 is equal to 0. Since a is 1, we're going to think, what can we multiply to get a negative 35? But add to get a 2. Well, it's a 5 and a 7. We want the 2 to be positive, so we make the 5 the negative. We make the larger positive. And so this is going to factor into x plus 5. I'm sorry, it's going to factor into x minus 5 and x plus 7. That's a little bit nicer, isn't it? Now, if two factors are equal to 0, then either the first factor, x minus 5 equals 0, or the second factor, x plus 7 equals 0. So then we would solve by isolating. We would get x equal 5 here. Subtract 7, or x equal negative 7 there. So we get x equal 5, or x equal negative 7. Now let's go back and find AB again. AB is 3x squared plus 10x minus 19, so we would have 3 times x, which is 5 squared, plus 10 times x, which is 5, minus 19, that's if x is positive 5. And so we would have 3 times 25 plus 50 minus 19, which is 75 plus 50 minus 19, which is 125 minus 19, which is 106. Let's plug in the negative 7 and see what happens. 3 times negative 7, trap it in, quantity square, plus 2 times negative 7 minus 19. I'm going to have to squish it in there. Start again. 3 times negative 7 quantity square plus 10 times negative 7 minus 19. Negative 7 squared is 49 times 3 minus 70 minus 19. 3 times 49 would be 150 shy of 3. 3 shy of 150, which would be 147 minus 70 minus 19, which would be 147 minus 89, which would be 58 degrees, or 58. We kind of got a couple of choices going on there. Any questions on that? Okay. That finishes that session of daily work. Again, I apologize that we got a little bit crazy. We made a little mistake right in here the first round. It didn't hurt us too bad, though. We did a bunch of crazy math, and it exposed us to some good stuff. Came back and did it right. Solution there for AB is 106, and you can plug in the 5 and find the others. Another possible solution there was 58. If you plug either one of these two in to find either of those three, if you get a negative in any position, then you have to kick that out for all of them. It could be that there's two scenarios that would work for. Okay? All right.